we come to division of terms. One thing it helps is to think of division as being the opposite of multiplication. And it applies in the rules that we're going to use as well. We're in effect going to use the opposite rule of what we used for multiplication. And you'll see why. So let's say we have 6a to the power of 4 divided by 3a squared. Okay, when we multiplied two terms together, we multiplied the coefficients. So now we're going to divide the coefficients. And remember, when we divide, the order matters. So it's going to be the left divided by the right. When we multiplied, we added the indices. Now we are going to subtract the indices. Which is the opposite of multiplication. And remember, for both of these, the order matters. So it's left to right, exactly how you would read a page. So let's do this one. We divide the coefficients. So 6 divided by 3 is 2. The a comes across. And now we subtract the indices. 4 minus 2 is 2. So our answer is 2a squared. How could we rewrite this problem so that we can use cancelling? Well, if we remember that something divided by something else, we can rewrite that in those terms. If I say we have 6a to the power of 4 over 3a squared, these are equivalent. Right, that is exactly the same as that. Rewritten. Same procedure. But let's, if you will, let's expand it out so we can have a look at how cancelling works. 6a to the power of 4 is 6 times a times a times a times a. And you can see why we use that, the indices notation there. Divided by 3 times a times a. And I'm using a because this is the form that will be given to you in your exam. Okay. Remember that a, any number, divided by itself, with the exception of 0, is 1. When we cancel, these numbers do not just disappear, they just become 1. So a over a is 1. A over a becomes 1. 6 times 1 times 1 times a is 6a squared. Both of those a's are now 1. 3 times 1 times 1 is 3. And now you see why this works. 6 divided by 3 is 2. We get the same answer, doing it longhand as we got using our rule. So let's have a look at the rule, and it's a rule, so I'm going to put it in red. The rule: a to the power of m divided by a to the power of n, where a, n and m are just any numbers, and this is how it will be given to you in the exam, so that's why I'm giving it to you using a, m and n. Is the same as a, m minus n. That's how it's going to be given to you in the exam. Let's do another example. 14 w to the power of 6 divided by 2 w squared. Well, using that rule and also remembering to divide the coefficients, 14 divided by 2 is 7, dividing the coefficients, subtracting the indices. 6 minus 2 is 4. The w comes across. That's how that's done. If we wanted to expand it, let's put a little line there. 14 times w times w times w times w times w times w. How many is that? 1, 2, 3, 4, 5, 6 of them. Over 2 times w squared, w times w. It's going to cancel, it goes to 1. It's going to cancel, it doesn't disappear, it just becomes 1. But then it's kind of irrelevant. 14 divided by 2, that's going to go to, we're going to divide that by 2, it's going to become 1. We're going to divide that by 2, it's going to become 7. And we're going to get 7 w 1, 2, 3, 4 over 1, which is 7 w to the power of 4. And sure enough, that is the equivalent to that. They're equal. One more example, just so you can get the hang of it. 9, let's say, x to the power of 10 divided by 3x to the power of 2. Well, we just follow the rule. The exponent, the coefficient, here is 9, the coefficient here is 3. 9 divided by 3 is 3. The variable is x, and we subtract. 10 minus 2 is 8, and we're done.